Click record. Let me take attendance. And let us begin. So let's see here. Nothing really new to say there, but I misnumbered all these. Today's lecture is lecture 26. I should remember that. And then the one on Wednesday will be lecture 27. There we go. So I'm almost ready to give us Pong. That's the goal eventually, to write Pong in Python. And to get there, we need to make that 2D bouncing program. All right, so let's do that. 2D bouncing time. So we're going to go off of the kind of stuff that we were talking about last time. We're just going to put it into code for once. And hopefully it will all make sense. So again, the game plan is to draw our little bounding box, our little window where our square is going to bounce, and then draw a square. And then it's just going to start bouncing around, having a good time. And hopefully maybe one time it's going to get to the corner, and that would just make our day, right in the middle there. So it's just going to bounce off every wall. That is our goal. That's what we'd like to do. So let's remember how we planned to do it. So we first have to draw the screen boundaries. That was step 1. And that was just the stuff that we can steal from our original or very first animation of the bouncing ball up and down. That's just that bounding square. No big deal. We can go like this. So it's supposed to be a square, but who cares? Got to draw that. And then we need to make a square in a random location within those boundaries. Let's go make a square somehow at a random spot. So maybe this is our random spot. Okay? And that square better appear within those boundaries. It can't like be way off over here. So we have to somehow constrain where the square ends up. And then we have to start it off. We have to give it, it would be nice if it were random, so it would be a different kind of program each time. So give it a random direction to bounce off in, or start at least moving off in, okay? So we got to set up this square with a direction. And I'll represent the direction by this just arrow thing, okay? And then we have animation, right? In order to make animation, we have to slowly move that box along its path and then bounce off the wall if it ever gets to one. So forever, move in your current direction if there's nothing in your way, because that's just how we animated things. That's how we moved the ball or the box up and down. Or no, it was a ball back then. That's how we moved the ball straight up and down. Nothing new, right? Move in our current direction if there's nothing in our way. It's just we have a 2-dimensional direction. We're moving a little bit in the X direction, a little bit in the Y direction. That's the new thing. So yeah, same as the bouncing ball, except we have a second axis. And then if we hit a wall, there are now 4 walls to worry about. We got to bounce off, okay? Boop, boop, and then we never want to stop. So forever, we forever do this. Move in our current direction. Hopefully we can. If we are hitting a wall during our current frame that we're trying to draw, let's bounce off, change our direction, make sure we stay within our bounds, okay? So that's our goal and our game plan. Let's talk about how we might code this now. So first of all, the turtle can be made to be the square, just like the turtle can be made to be the bouncing ball. It'll be the bouncing square too. So we'll do that. And then we have coordinates for our turtle, right? He always has an X and a Y. That is his midpoint. Yeah? So we got to save that. And then if we want to go somewhere with that turtle, we have to save that direction. Again, we can use offsets, right? We can use, if we want to represent a horizontal direction, we need X offsets and Y offsets, okay? Nice 90-degree there. So some sort of X offset, some sort of Y offset that we will program. And just the combination of those two, we can move in any direction, right? You pick me a spot along an angle around a circle you want to move. You want to go over here. It's just go a little bit left, go a little bit up. You want to go down this way? Go a little bit down, go a little bit left. Wherever you want to go, no matter which direction. Doesn't matter. So you can always make it based on those 2 offsets. And yeah, when we move, when we animate, every frame we want to draw a new thing, we want to put the turtle in a new spot, we have to, in order to move diagonally, move a little bit by our x offset, move a little bit by our y offset. Okay? That's the goal. So no matter which direction I'm trying to go, if I'm trying to go up and to the left, it's go a little bit in the negative x direction, go a little bit in the positive y direction. Yeah. If I'm trying to go down and to the right, it's still pretty much the same. It's just go down in the y direction, go right in the x direction. Still a nice 90-degree right triangle. Okay? Any questions about what's going on here and what we are going to set out and do? Okay? Because I want to get at least this much going. I want to get the turtle in a random spot and with a random direction. Okay? That's what I'd like to do, and then we'll worry about the bouncing next. We all like this idea so far? Okay. So I will open up idle now. And was it lecture 26? Yeah, today is lecture 26. And I also want to steal the bouncing ball program from before. I think I just called it bounce, right? 24 bounce. So I'm going to copy that as our original bounce program. I'm going to steal that and reuse it today, just like I reused it last time. So I'll make a new program. And I said lecture 26, right? Yeah. And what do I want to call this? I don't know, 2D bounce.py. And so I'm going to paste in our old bouncing code, just our normal, make the turtle a circle, bounce up and down. So this is what I'm going to start with. That code. Well, that's what I'm going to start with. And then we're going to change a few things. Okay? We're going to start moving in many directions. So let's change those things now. So the first change that needs to be made is the turtle is now a square, not a circle. So let's handle that. That's pretty easy. So turtle.shape square. We can still have them be pink. That's fine. And just to make this easier on us, let's say turtle dot. Is it just speed? I forget. I think it's fastest or something. Let's see if that complains. Yeah, much better. Okay, cool. So that's what I want. And now we have a bouncing square. Cool. That's useful. All right, next step. We want to start our turtle in a random spot, right? A random location within our boundaries. So what does that mean in terms of what we have? Let's see, where could he start? Where could he finish? So it looks like my initial location for this turtle was a random X position and always at the top of the bounding rectangle because we were dropping it from the very top from that program. So I think I can just change this to be another kind of random.randint call, and it will then be a random Y position as well. Okay? Well within our bounds. So I could have made it like negative 180, positive 180 or something, but this is kind of centered within our bounding square. So now I have a random X location and Y location. It doesn't start from the top anymore. Okay? It's hard to get all this on the same spot for us, especially because this highlights everything. When I start it, there we go. Let's put this over here. So yeah, all I've changed so far is make the turtle a square now, please, and also give him a random starting position. Okay? If I rerun it, I'll get another random starting position. So it was somewhere here on the bottom right. Okay? So that's nice. We have a random location to begin with, and now we need to worry about random direction. Okay? Give the square a random direction to start, and we're going to use offsets again to store our direction. They're going to be random, and we're going to need two offsets. Okay? An X offset and a Y offset. Any questions before I do that? Because that's going to be a new, like a lot of code to change. We're all happy with what I have so far, yeah? All right, so we need offsets. And so I had just a single offset before, that was for the Y direction, but now we need multiple offsets. So we have, I don't know, X offset and Y offset, okay? In my diagram, I'm calling them X off and Y off. Maybe I'll just call them this here. So we need a random starting direction, okay? And think about it. What is a random direction but an arrow in a certain location? It's a certain X offset and a certain Y offset. A direction, though, we would like to be normalized. I don't know if any of us have taken like physics or linear algebra. If you have, this word should be familiar to you. But we would like this random direction. We'd like the turtle to shoot off at the same speed no matter the random direction we pick. Okay? So this is something I'd like to do right now, is make sure that no matter which direction we pick, that turtle shoots off at the same speed. Because what could I do right now? I could pick this baby tiny little offset with tiny X's and tiny Y's, or I could pick this giant offset in the same direction, couldn't I? Move a bunch by X and move a bunch by Y. Okay, do we see how these are the same direction, but they'll force the turtle to move at different speeds? Does that idea make sense to us? This is a new interesting topic. Okay, so these are the same direction, but the offsets are completely different. This is like baby X, baby Y. This is like giant X, giant Y offset. Okay? So a frame later, like the square will have moved here versus will have moved way over here. Yeah? We'd like to normalize that. So we'd like our turtle to be able to move. We want to normalize this. That's the word. So that our turtle, no matter which direction we pick, is kind of like the size of that offset, the size of that arrow is like always along a circle. It's always the same radius. So if we want to shoot off this way, make that be radius 1 always. If we want to shoot off this way, make it be radius 1 always. If we want to shoot off this way, make it be the same length no matter which direction we're going. Does that idea make sense to us? Because it's going to take some math to make sure that we always shoot off at the same direction. That this hypotenuse of our offset triangle is always equal to 1. Okay, that's our goal. Let me write that here. Normalize the offset triangle so that the hypotenuse, that distance that we travel every frame, is exactly 1. Okay? That's a nice normalization constant. Go by 1, please. 1 at a time. So here's how we can do that. To pick a random direction, I just need random numbers, right? Think of what it means to be a random direction. I just need to go a little bit in the X, a little bit in the Y, no matter what. I could go in the positive X direction, and then in the positive Y direction, that will shoot me here. I could go in the negative X direction, and then the negative Y direction, that will shoot me off this way. I can go in the negative X direction, the positive Y direction, that will shoot me off this way. I can go in the positive X direction and the negative Y direction, that will shoot me off that way. So it seems to be that if I just pick a random offset for X and Y and have them be between -1 and 1, I have all the possible directions, yeah? So that's my goal. So pick a random offset. Our offsets will both be between -1 and 1. Like if you pick -1 for the x, you'll shoot off that way, and you pick positive 1 for the y, that means you're going diagonal. Diagonal up and to the left. Yeah? Does that make enough sense to us? That's how we want it to work. So let's pick some random offsets, and I need to pick some random numbers. So Python random. I need random floating point numbers. I want every possible range of offsets. So I don't want rand int. I want, not like this. I want rand, let's see. Was it rand range? Oh, here we go. Random.uniform. A random number with decimals included are possible between A and B. Okay? So on a random number between -1 and 1 for each offset. Random.uniform. -1 and 1. Okay? And again, random.uniform. -1 and 1. Okay, so now I have my offsets somewhere between -1 and 1. And the idea is what I could have gotten might look like this, or it might look like this. My direction, my random direction to move off in. It could have randomly picked like tiny 0.25 and 0.25 for x and y offsets. And so it's moving up and to the left perfectly, off 45 degrees, but slowly. Or the random.uniform could have given me back all the way 1. 1 for x and 1 for y. And so the same direction, like if this were 1, this were also 1, it would be in the same 45-degree direction, but faster. Okay, so I'd like to normalize that. No matter what I got, keep the direction, but normalize that length of the hypotenuse so that we move in that same direction with a constant speed, no matter which direction we pick. Okay, that's our goal. And so in order to do that, what we need to do is figure out the current length of our hypotenuse, and then if we just divide both of these by it, it should work out. So we want to normalize this. Let's normalize our offsets so that the, I don't know, that one, x squared plus y squared, the square root of that is equal to 1, right? So that the hypotenuse is 1. Okay, the hypotenuse of our direction triangle, of our offset triangle. That will let us move at the same speed. No matter what random direction we pick. That's our end goal. So let's make sure that happens. So let's calculate the current hypotenuse. I'll call it hype. I'm going to need math for that, so let's import math. Because I need square root. So what is the hypotenuse of a triangle but square root of x squared plus y squared? X offset squared plus y offset squared. That'll get me this length here. Is it moving just a little bit or a lot of bit? And then I can divide both of these offsets by that size, by that hypotenuse. If it's already 1, I'm not changing anything. If it's a little bit bigger, I want to make both of these smaller so it comes back down to 1. Yeah, that's my goal. So now we can divide both. Divide the offsets by the current, or by hype, I guess, let's say, to normalize the length of the direction. 2D direction. Okay? This is secretly called a vector. It's a direction vector. We've taken fancy calculus or linear algebra before. That's what we're doing. We're normalizing the length of this vector. All right. So I just want to change the x and the y based on this hypotenuse. X is equal to whatever it used to be divided by hypotenuse. And same for y. Whatever it used to be divided by the hypotenuse. And that'll force no matter which of these I got, the size of this hypotenuse is much smaller than 1. The size of this hypotenuse is like root 2, right, which is bigger than 1. It'll force it to be just right in between a constant length of 1. It's always on that radius 1 circle. Okay? So that was a lot of work just to make sure we always shoot off in the same direction. Are there any questions about what I just did? That's to make sure we don't randomly move super slowly sometimes and super fast other times. It's so that this direction that we picked is always going to lead us off with the same speed. Because, as we remember from before, the size of our offset kind of governed how fast we moved. A bigger offset meant faster speed for the turtle. Okay? So that is all that kind of normalization. And then we're ready to actually go and use that direction to move the turtle each frame. Okay, so each frame, move the turtle's x-coordinate and y-coordinate by the direction's amount, by how much that offset is taking us in the x direction, by how much that offset is taking us in the y direction. And that will move us potentially diagonally. So, where was I messing with directions? So, I was doing it all here in the draw frame function. So I had turtle x and turtle y, and now I want to change both, so I'll make them both global. And then now the offsets are named x offset and y offset. So I'm going to eventually have to change those when I bounce off the walls. So I'm just going to make sure that those are global here too. The reason I put these globals again is just so that because I'm inside of a function, it gives me the ability to change a variable that was defined outside of the function. That's what it's doing there. All right, so now I can use this stuff. If we hit a wall, bounce off, let's deal with that later. We'll worry about this all later right now. Let me actually just get rid of this code just to make sure it doesn't run. Let's not worry about bouncing into the wall right now. This is like I put a bunch of comments on it, so this code doesn't run right now. Let's just worry about moving in our current direction, okay? Change the turtle's x and y coordinates, plural, now, by the offsets, plural now. So turtle y changes by the y offset. That's our direction, in the y direction. And then turtle x changes in the x offset. Whatever direction that was, positive or negative. And this will shoot us off, potentially diagonally. I say potentially because we could have randomly picked 0, right, for one of these offsets. And that will just move us in a straight line, up, down, left, or right. That is possible, but quite unlikely. All right, so yeah, now instead of moving in just the y direction, changing our coordinates by just a y offset, now we're considering our normalized x offset and y offset together, okay? And then we just redraw our square in the new place that we updated these variables to be, and the turtle has moved in a direction, okay? So I guess drum roll please, let's see what happens. Whee. So it looks like we did more or less pick a horizontal direction, which is cute. That was randomness for you. Let's see if I rerun it. We should get another random location. Yay, look at us go. Up and to the left this time, and off the screen. Isn't this fun? Up and to the right this time. So the x offset was positive, the y offset was also positive. And off the screen we go. Then it was down and to the left. So the x offset was negative, the y offset was negative. And down off the screen we go. Nice. So it seems to be working. Any questions about what I had to do to get us to this point? We're off, we're bouncing. We're not bouncing yet, but at least we're moving in a two-dimensional direction. Isn't that awesome? So I'm excited about this. All right. So the final piece of this puzzle is to make sure we stay within our bounds, right? We would like to hit the wall and bounce off perfectly. Right now we are not doing that, so let's fix it. Okay? So we talked about this last time. Let's just make sure we all still have it. So in our code, the turtle is going to hit the left wall when the x-coordinate is less than or equal to 180, or negative 180, instead of 200. And let me show this, let me prove to you why. Here's our bounding square. Try my best to get this to be perfectly straight. And remember that we centered this square around 0, 0. Here was the origin. Here are our axes in turtle land. All right. So I claim that the turtle hit the left wall when its x-coordinate is less than or equal to negative 180. And let me show you why. Okay. These are 200, right? This point right here is negative 200, positive 200. Like this wall exists at x equal negative 200, right? That entire wall. And the issue is, the reason we have to use negative 180 instead of negative 200 is because the turtle considers its coordinates relative to its center, okay? So really, if we're right here and we hit the edge, we just barely grazed the edge as the turtle, it thinks of its coordinate as right here, its center. And the size of our turtle, we have realized from before, happens to be 40. Okay, so the turtle's 40 by 40. So when it hits this left wall, for example, what is its x? It is, well, it's right half of 40, right? It's negative 200 minus half of 40, which is, plus half of 40, which is negative 180. So that is why we have to worry about not this wall with this line, but kind of this wall with this line, which is x being negative 180. Does that make sense? So if we're on it, we're right there, we're touching it, we're equal to negative 180. And if we somehow try and go past that wall, we are strictly less than negative 180. Yeah? So that's essentially the wall point for us. And you could think about this in terms of all the others as well. So like we're right here, we're hitting this top wall. This is something we did before. If our center is somewhere greater than or equal to in the y direction, that's 180, positive 180. Y equals 180. Yeah. And then same here, if we're on the right, that is, if we hit this wall, our x is perfectly equal to positive 180 on the x. And then if we're down here hitting the bottom wall, it's our y that matters, and that is less than or equal to negative 180 in the y. Okay? So that's where we are. That's how we know we're on the edge or over the edge. Does that make sense? It's just two new axes, or two axes total instead of just one from before. And then we have to bounce off. Once we notice we're here, we need to bounce off. Okay? Let me show this to you. And gosh, do I want to do this now or later? I guess let's try it now. So here's what I had from before. Here's the code we had before. If we hit a wall, bounce off. It looked like this. This was for the top wall. This was for the bottom wall. And we also might hit the left or the right wall, so we need to consider those. Okay? And we also have to like change the way we're bouncing off. Like this all makes sense right here. But like I changed these variables. There's no variable called turtle offset anymore. We need to figure out which one to change and deal with that. So I think let's draw the answer first, like we were talking about before, and then maybe we can just put it all into a function. So let's say we hit the left wall. Okay? Let's say we hit the left wall. Let's remember what we need to change. Okay? What do we need to change in order to bounce off of that left wall? So let's say we're right here. We just touched the edge. And our direction was, like the reason we came in here is because like we were going right here, up right here, right here. Our direction was off this way, right? trying to take us out of the bounding square, and that came along with some kind of x offset and y offset. This was an x offset, this was a y offset, that was a right angle. So that was the direction we were trying to go in, but we hit the wall. And we need to bounce off in exactly this direction, right? That mirror direction, which involves, well, it's the same size triangle, but the offsets might be negated, okay? What is our goal? So we were moving to the left and up before. We're still moving up, so the y offset doesn't change in our new direction, our bounced direction. The y offset doesn't change, but our x offset that was taking us in the negative x direction before, to the left, now becomes positive, okay? So this new offset is the negation of the old x offset. Take us in the other direction, please, okay? That's what we need to change. And this works for no matter the axis. So it looks like when we hit a sidewall, it's the x offset that needs to be negated. If we hit a top or a bottom wall, that means that our y offset needs to be negated. So if we were coming in like, I don't know, if we were coming in this way, and that's how we hit the edge. Again, we were moving down and to the left, but now to bounce off in this direction, we need to move to the left still, but now up. So that's a negated y offset, okay? Any questions about what's happening there? And I think I want to put all this into a bounce if hit wall function so that I don't have to put all this code in one giant spot, okay? So I can just be like, bounce if hit wall. And then I'll worry about this kind of bouncing stuff later, up in a different function. So that makes this function much cleaner, this draw frame function. Like all the bouncing stuff happens in our bounce if hit wall function, okay? So with that, let's go here. Let's make this function, this bounce if hit wall function. Def bounce if hit wall. And here is what we need to do if we hit, for example, the top wall and the bottom wall. That's the code from before. And so I'm going to be changing my offset and my locations again, so I need to add these into this function, just to say that I may be changing these variables' values. And now I need to worry about bouncing off. Okay, so back to here. Negate the x offset of the direction if you hit a sidewall, negate the y offset of the direction if you hit the top bottom walls. Okay? And you might, well, let me just do it first, and then we'll worry about some things that might go wrong later. Okay? I'm going to do it right the first time, though. So we know we hit the top wall, just as before, if our turtle's y is less than or equal to negative 200 plus turtle width over 2. That is negative 180. Yeah? If we did that, we need to rein the turtle back in to that exact edge, right? If we tried to pass it. If we were, I was here, he was down here, I was trying to go down here, bring him back up to be inside, right on the edge, and then also change our direction to bounce off. This is all the stuff that we've done before, but it's not just a single offset to change anymore. If we bounced off the top and bottom walls, we negate the y offset now, okay? Change the y offset so that we move upwards now, and in the same x direction, okay? Turtle y offset is turtle y offset times negative 1, okay? And the same is true for this, this was the bottom wall, and this was the top wall. The same is true for the top wall. If we ever try to go over, or y ever goes over 200, minus the turtle width over 2, so it's over 180, rein the turtle back in to be right on the edge, and also change his direction. Okay? So this reining in is still fine, but it's always the y offset that needs to change. Okay? You need to change the offset so they move downwards now. Okay? So those are those walls, and you can definitely not get to both of these pieces of code at the same time, right? So it's totally fine. Like, you can't hit both the top and the bottom wall at the same time. That's impossible. So it's okay to have this be like an if-elif. That's not an issue. One or the other, please. That's totally fine. And this is top wall. because you can't hit both at the same time. But if I want to consider us hitting the left and right walls, I need to keep in mind that we might hit a corner. We might hit this corner right here, just like the Office episode was so excited about. We might hit this corner coming off right at that angle. We want to bounce off right at the other angle, which will involve us having to change our X offset and our Y offset at the same time. This involves us hitting the right wall and the top wall at the exact same time. Does that make sense? So, because we can hit a side wall and a top or bottom wall at the same time, I can't make a bunch more LFs here. I'm not allowed to do that because it's only ever one. I'll only ever worry about hitting the top wall or the side wall, not both. Because both can happen at the same time, I need separate if statements so that they can both have the potential of being run. Okay? That was a lot of words. I hope that made enough sense. Please yell at me. Okay? That's the reason we need two separate if LFs, or you can just have a bunch of ifs. It doesn't really matter. Okay? But you can't just put it all in one big if, LF, LF, LF. That would not work, because then we couldn't hit that corner properly. We would not bounce off properly. Okay? So essentially, the left and the right walls are pretty much symmetric to these. So I can copy this code. Let's be like, this is the left wall, this is the right wall. But what needs to change now? We know we hit the left wall if our X is too small, right? Oops. If our X is too small, we're trying to be over here. Okay? So if turtle X is less than that, we hit the left wall. We need to move the turtle back inside, if we did. So turtle X equals exactly that. Put him right on the edge in the X direction. And then the Y offset is not the thing that needs to change anymore. We need to change the X offset so that we move. We were moving to the left, right, in the X direction. We're trying to go this way. We need to move to the right in the X direction now. I guess rightwards now, that's a word, yeah. So just negate your X offset so that we move in the opposite direction. If we were moving left, we hit the left wall. That means we need to bounce off to the right. That's our idea. Same for this one. If we hit the right wall, that means our X was too big. It was way over here. We need to rein the turtle back in right on the edge, please. Go right on the edge in your X coordinate. And then change the X offset so that we move in the other direction. So the only way we hit this wall is if we were moving to the right. We need to bounce off now to the left. Negate your X offset. Okay? So we move, I guess, leftwards. That's not a word you say every day. Okay, negate that offset, and that is how we bounce. Okay? So that is our bounce if hit wall function. If we hit the bottom wall, we need to worry about reining ourselves back in, changing our offset. Same for the top wall. It's our Y offset, though, because that governed how far up or down we were going. We hit a top or a bottom wall, so we need to move in the other direction relative to those walls. And then for left and right, it was the same, but for the X. If we're moving too far to the left, we need to start moving to the right again. If we're moving too far to the right, we need to start moving to the left again. Okay? Any questions about this code? This was, I had to change what we had before, but hopefully that was not too bad. And then we had to bring in some similar looking code to deal with the new walls that we hadn't considered in our old bounce program. And I think, if I didn't do anything silly, we should have a functioning bouncing program now. Whee! Oh yes, isn't that satisfying? Ooh, we might hit a corner right now. Almost. We hit the right. We hit the bottom. We bounce back up. We change the direction of our offset. So again, the code doesn't look too bad for our main loop, for our draw frame. It's this right here, right? Here is our draw frame. Here's our pretty picture. It's always, okay, move ourselves by our current offset for the next frame. Move in our current direction, whatever our direction may be. Bounce if we hit a wall. Isn't that nice to have put that all into a function to have us worry about it in a different place? That makes this function so much easier to read. And then once we've changed potentially all of these variables, x, y offset, if we hit a wall including, then we just actually move the turtle to that new place that it's supposed to be. Okay? And so forever, draw a new frame, we have animation. It's beautiful. And our bouncing if hit walls, they're working perfectly. Like we're about to hit the bottom wall, which means this is going to become true. We're going to have gone too far a little bit in our frame. These two pieces, these lines, will have moved the turtle a little bit too low. And so we need to move the turtle back inwards, bring him back in to be within our bounds, and make sure he bounces off in the new direction. Okay? Bounce off with a altered Y direction, for example. Okay? Ooh, that was almost the corner. And the reason we needed two if-elifs is because we might have hit the bottom and the left wall. We might have hit the top wall and the left wall, for example. We need both of these to fire, potentially, on the same frame. Okay? So, let's rerun it. Let's get a new, almost perfectly to the left direction. And that's our program. I think that's everything that I wanted to say. Are there any questions about this? This is a very nice culmination of a lot of things that we've learned, I think. Any questions about what we just did? If I wanted to make the turtle move faster, what should I do? Yeah, it's still about the offsets. I took great care to make sure that they were all normalized in a certain way, that the hypotenuse was always length 1. But I can make sure that the hypotenuse is always length 2 by putting a times 2 here. Good. That's totally fine. And so now when I rerun it, the turtle will move twice as fast. Maybe we prefer that. And you can keep going. Let's double that. Let's make it 4. Oops. Woo! That might make you dizzy, but that's what's happening. Maybe we prefer this. This is pretty cool looking. That's like the speed of Pong, maybe. But yeah, that's fun to play with, and all you need to play with is the length of your direction. The length of that arrow, which is the hypotenuse of those offsets. Okay? So I'll comment out this times 4. Maybe you can bring them back in if you prefer. But that's what we had. Yeah, okay. I think that's everything that I wanted to say for this program. If we're still okay, I have one last thing to show you today. So, again, the reason we have this is because I want to make Pong again. The reason we're doing this is so that I can show you how to make Pong in Python versus Scratch. And so this is the ball, of course. The last piece of the puzzle is have a little paddle on the left, right? That can move up or down. That is what we still need. So to get there, I need to teach you about how to move something with the keyboard in Python, okay? Because our goal is Pong. That's where we're headed, all right? So we need to make this work somehow. We need to get information from the keyboard, which we have not yet been able to do. There better be a way, hopefully. We need that to make our Pong, all right? So let me make a new program that gives us a paddle, okay? Let's set up our game board as usual. Let's keep that same square, same bounding square. And let's not worry about the ball anymore. We just worked on that all day. Let's get rid of the ball and make a paddle instead. So here can be our paddle, okay? We want it to be right there. So let's deal with that. Let's make a paddle somewhere on the left. And I want to call this, I don't know, I'll call it paddle.py or something. And so let me steal most of what we had, and let's change what we're doing here. So I don't need animation anymore. I just want to make a paddle. 2D bounce, so I'll just minimize it for now. So most of this I'm going to get rid of. So I need the draw rectangle still, bounding square. We're going to make the turtle a paddle now, which is more or less what we did before. And then, let's see, turtle X, turtle Y. Maybe I'll call this paddle X and paddle Y. and then I'll worry about going there. Go to paddle X and paddle Y. Okay, so again, bounding square. Make the turtle a square right now, and then put him in a random spot and go there. So no animation right now. Let's just get the paddle looking like a paddle. What have I not done? So I forgot to put the turtle up when I moved him to that random location, so let's do that. Turtle up. And I guess we never need to put him down, actually, so we can just stay like that. So let's make the turtle a paddle-like shape. Okay? So when I stretched him, I did this. I said turtle.turtle size 2 times 2. So take whatever original size you were. Like if I get rid of this line, for example, here's what the turtle will be like. That's his default size as a square. I stretched him by 2 in the x direction and by 2 in the y direction. That's what this turtle size 2 did. I would like to stretch him in a different way now. I'd like to stretch him more, right? I'd like to stretch the turtle more in the y direction than the x direction. That will make it look like a paddle. That's the idea. Turtle needs to be stretched a lot in the y direction. So let's do that. So I don't know, gosh. What did I want this to be? Maybe like 6, maybe? 6 in the y direction and 2 in the x direction, let's say. What does this look like? That's nice. The paddle looks kind of fat right now, actually. So let's see if we can, maybe we can stretch him by, I don't know, 1.5 in the x direction. That looks like a paddle. Yeah? 1.5 in the x and 6 in the y. That seems good to me. So, gosh, how wide do we think this is right now? I think, let's remember this. We did 1.5 in the x direction. And then 6 in the y direction. Based on what we had before, that means that the new, like when we stretched it by 2 and 2, the square was 40 by 40. So with that in mind, I think that the original size was 20, something like that. So that should make this now 30. The width is 30. And then the height is, I did it by 6. That's 120, I believe. That's what the paddle is. And now we need to get the paddle on the left. Okay? We can kind of like hard code that, I think. The default x and the default y. Let's not make it random. Let's make it hard coded. Let's say that the x is like, I don't know, negative 170. And then the y, let's just make the y 0. Start kind of in the middle. Paddle should be now. So there's my paddle. Starts, yeah, it looks good enough, right? Somewhere on the left. And within the bounds, so that was negative 170. That was a good first guess, I guess. And then paddle y is 0. So right now he's centered right at y equals 0. So that's my paddle. And so that's what we know how to do so far. I need to now get this paddle moving with the keyboard. If I press up, the paddle should move up. If I press down, the paddle should move down. Let me teach you how to do that. So, luckily, the Turtle library comes with keyboard controls. We can use the keyboard as input to the Turtle, and here's the kind of thing we need to use. Here's the library function. It's turtle.onKeyPress. Let me show you that in the Turtle documentation. .onKeyPress. You say onKeyPress, or I guess also onKeyWorks. Looks like that's what it's doing too. Either way, I guess, I'm going to use onKeyPress. And you give it two things. You give it a function. You pass along a function to a function, which is cool. And then also you give a key. Okay? And that's the key you want to have affect things. So you say turtle.onKeyPress, do this cool thing when the up arrow is pressed. You just say up as a string. And it calls this function f every time you press the up arrow key to move the turtle. It's really cool. Okay, so that's all we need to do. Dun, dun, dun. And then the final thing is we have to say turtle.listen after we've set up all our keys to make sure that the turtle starts paying attention to our keys. Because by default, like I press the up arrow, nothing happens. We have to ask the turtle politely to listen for our keys to be pressed now. That's all. So I'll say turtle.listen after I set up my key handlers. Okay? That's what we're doing. And so, yeah, the idea is we're saying set up functions to run every time the up/down keys are pressed. That's what we're about to do. I'm going to say turtle.onKeyPress. I don't know. I'll make a function called goUp. And I want that to happen whenever I press the up arrow key. And then similarly, I'll make a function called goDown. And I'll have that get called whenever we press the down arrow key. And I'll have the turtle be listening for these now. Listen for my key presses, please. So the last thing I need to do is make these functions. Whenever the up arrow gets pressed, the turtle's going to call goUp. Whenever the down arrow gets pressed, the turtle's going to call goDown. So I need to make those functions so that it can call them. So let's make def goUp and def goDown. So what needs to happen when we press a key? We need to change the location of the paddle, right? So I don't know. Let's use these variables still. Global paddle x. I want to change it. Or technically, we'll keep the x in the same. We're just going to change the y location, right? So global paddle y. And if we want to go up, that means paddle y needs to be increased. Whatever the old paddle's y location was, we need to make it bigger. That moves the paddle up. So go up by, I don't know, plus 10 for now. Let's try that. 10 units, and then go there. So that's my goUp function. So every time we press the up key, it's going to call this function for us and change the location of the paddle to some new location, some higher location. Okay? So let's go up, and then go down is symmetric. So it can be like go down, paddle y equals whatever it was, minus 10. So it's a lower y direction. Yeah? And these are my two functions. They'll get called whenever I press a key. So here's my code, here's my screen. I'm going to press the up key. Ooh. I'm going to press it a million times, and the paddle moves up. I can even hold it in, it kind of moves longer. So now I have movement based on my arrow key presses. Isn't that so cool? It's calling those functions for me to change the location of the paddle, which is the turtle. Any questions about this? This is beautiful. The last issue, does anybody know, can you think of an issue that might arise right now? What have I not yet done properly? What am I missing as far as the paddle is concerned? What's that? Yes. Sorry, I couldn't hear you well enough. That was exactly right. Because if I go up here, oh no, we don't want the paddle to go that far. We need bounds checking, exactly. We need to make sure that when the paddle hits the top wall, he doesn't move farther than the top wall. Same for that bottom wall. Good. We don't want him to go farther past it or outside, so that's no fun. So we need to make sure that if I press up and I'm like right here, up does nothing now, right? I shouldn't be able to press up and go any farther. Up should just do nothing. We've already hit the top, okay? So that's going to involve us keeping track of where the top is from the turtle's perspective. So if these are correct, and I think they might be, we need to figure out what does it mean for the paddle to be right here. What is its y location? So if it really is 120 tall, and this is y equals positive 200, right? That's the line right here, y equals 200. Then this is how far we want it to go relative to the turtle. That is, if it's 120 tall, that's 60 is half of it, right? So this is y equals 200 minus 60, which is 140, I think. I believe. So let's see if that is the right way. I'm not sure if I got it right yet, though. I could be off by 2 or something. So if we want to go up, that's where we would like the paddle y to become. But if we hit the top wall, make sure we don't go past the top if we did. So if our paddle y is greater than or equal to our top wall, which is 140, I think we guessed, then make sure that we don't go any farther. Paddle y, set it equal to 140. Okay? Make sure it can't go past it. And so we just stay there. We just stay there if we try to go farther than it. Okay? That's our goal. Let's see if I got those calculations right the first time. Yeah, look at that. So that was correct. Cool. So 140 was the top wall. I'm pressing up right now, and it's not letting me go any farther. That's beautiful. I don't have to worry about left and right because I didn't set up the left and right arrow keys. So now I just need to worry about the bottom. Same thing. Make sure that we don't go past the bottom is the same idea. Try to go that way, but if you got too small, I assume that's negative 140, right? Then set the y to be negative 140. Okay? Don't go any farther downwards in the y direction. Stay there. Stay at negative 140 if you're trying to go even farther than that. So now I can press up. Hold it in, hit the top wall, can't go any farther. Press downwards, moment of truth, and I'm stuck. Oh yes. Isn't that satisfying? So definitely study this code, get it working, get it straight in your mind, because to make Pong, all we need to do is connect these two programs that we made today. Worry about bouncing off the paddle as well, but that is about it, right? That is legitimately Pong. We've almost made it. Isn't that super exciting? I'm excited for you. So, yeah, are there any questions about this or anything else that we did today? These are exciting times. You see how much extra work it takes to get Pong in Python as opposed to Scratch, right? But it is satisfying nonetheless. So yeah, that's everything that I had for this today. Let me just make sure I have nothing to say beyond that. Yeah, on Wednesday, I want to talk about your final. So make sure I talk about that then. But that is all that I have for you today, at least.